Hi everyone, welcome and thank you all for joining today's webinar on developing mathematical mindset in students. My name is Ravali and I'm a part of team here at Turito. I'm joined here by today's speaker, Mr. Vasu, Head of International One-on-One Tutoring at Turito, and Ms. Priyanka from Student Counselor Department. This webinar is an outreach program by Turito for students to help in developing their learning skills and for parents who are willing to give their children best education. Before we start off, let me give a quick overview of organization. And all you are aware, Turito is an e-learning platform and our vision is to provide quality education to every student by well-experienced faculty. Currently, Turito is available in USA, Canada, Middle East, India, Singapore, UK, and Australia regions. And programs offered by Turito are NAPLAN OC and one-on-one tutoring services for math, science, and English subjects in Australia region. Turito exclusives are Turito offers interactive learning methods, as per students' requirement, regular assessments to track the child progress, and also doubt clarification sessions for making their concepts stronger. Turito also provides parent app access to make you a part of child's learning journey. Moreover, we have top 2% certified educators whom we partnered with to envision our mission. Before getting into the specific, let me offer a quick intro about our today's speaker at event. Mr. Vasu is an international one-on-one tutoring head and he is a holder of Master of Mathematics and Bachelor of Education with a vast experience of 30 years in education industry. He is a IITN Foundation content preparation expert and mentored 80,000 plus IIT qualifiers and 4,000 plus SAT and ACT scorers. Also, we are really glad to have Sir here because he had taught many more students from international and mentored ACT and SAT scorers from international as well. Thank you, sir. Over to you.
Yeah, a warm welcome to everyone who has joined the webinar. Now, first we'll see the introduction to math. Mathematics is a powerful tool that helps to understand the world, encourages logical reasoning, critical and creative thinking, and problem-solving ability. Mathematics is a science of structure, order, and relation that has evolved from elemental practices of counting, measuring, and describing the shapes of objects. It deals with logical reasoning and quantitative calculation, and its development has involved an increasing degree of idealization and abstraction of its subject matter. Since the 17th century, mathematics has been an indispensable adjunct to the physical sciences and technology, and in many more recent times, it has assumed a similar role in the quantitative aspects of the life sciences. In many cultures, under the stimulus of the needs of practical pursuits such as the commerce and agriculture, mathematics has developed far beyond basic counting. This growth has been greatest in societies complex and the opportunity to build on the achievement of earlier mathematicians. Now, moving ahead, the origin of maths. Now, here, mathematics has originated from the Greek word meaning tendencies to learn. Multiple branches, numbers, geometric forms, algebra, and others. Mathematics is a historical subject. It has been explored by various mathematicians across the world since centuries in different civilizations. Archimedes from the BC century is known to be the father of mathematics. He introduced formulas to calculate surface area and volume of solids, whereas Aryabhat, born in 476 CE, is known as the father of Indian mathematics. In the 6th century BC, the study of mathematics has been with the Pythagoras as a demonstrative discipline. The word mathematics originated, as I told you, from the Greek word mathematia, which means subject of instruction. Another mathematician named Euclid introduced the axiom, postulates, theorems, and proofs, which are also used in today's mathematics. History of mathematics has been an ancient study and is described by each part of the world in a varying method. There were many mathematicians who have given different theories of many concepts which are been applying in modern mathematics. Now, moving ahead into the maths in daily life. It is the study of measurements, numbers, and space. Maths plays a vital role in all aspects of daily life. Example, time tracking, driving, cooking, or jobs like accounting, finance, banking, engineering, and software. Almost every student studies math during school. However, the majority of teenagers question the importance of math. Still, it is one of the most critical subjects to everyone. Most students are unaware that maths is not just a part of many other disciplines, it is a part of everyday life. Mathematics is needed almost everywhere, be it engineering, science, or other technological disciplines. Indeed, science as well as technology would not exist without math. In order to analyze data, recognize certain patterns, and prove facts, one needs to apply math. Only then we can understand complex information. Almost every career involves math. Scientists needed psychologists, and even cashiers. This is the reason why every student has to learn math in school or in college. However, many students do not take the subject as seriously as they should. Many of them say that they do not want to get a job that involves maths. However, we do not only need math in certain careers and in science, actually, it is a part of everyday life. Whether we go shopping, play video games, or cook dinner, Max is always present. Indeed, life as we know it would not be possible without math. Therefore, every student should pay attention when studying math at school. Moving ahead, now understanding the basic concepts in lower grades. Math skills and concepts build on each other from grade to grade, which is why children need to get a firm foundation so that they can handle the more complex challenges as they progress in school. Now, for example, if you take the numbers, for example, if you take the numbers and counting will form a significant part of your child mathematics lessons. Count and write numbers from 1 to 100. Count by ones, twos, fives, and tens. Count backward. Count onward from any number. Count backward from any number. Addition, subtraction, multiplication, and division. Now, the 2D shapes, for example, what are the number of sides, faces, etc. Name of the 2D shapes. Like the 2D shapes you have is a square, a rectangle, parallelogram, rhombus, you have kite, all these examples you have. Now, sorting and patterns, fractions, number places, time. Now, in time, actually tell the time to the nearest hour, half hour, and quarter hour, sometimes even to 5 minutes. Make the connection between time and events. Example, shorter, longer, after, before. And in measurements and comparisons, when you come, it is length. Now, length is it in kilometers or meters or centimeter, whether it may be weighing, for example, kilogram, grams, milligram, centigram, like that. So everywhere, math is very useful, right from the lower grades to the higher grade. Moving ahead, now how to develop skill in fast calculations. Mathematical calculations come up frequently in day-to-day life, and there is a lot of benefit to being able to tackle a problem without resorting to a calculator. Whether you are short for time in an exam or just calculating, working on your calculation skills is a beneficial way to expand your memory and keep your mind sharp. Do speed addition and subtraction tests. For example, speed drills must be made in addition. Now, how you add so that you get 100, what numbers to be added or what numbers to be subtracted. Now, doing a lot of problems on addition, subtraction, and again, uh, addition and subtraction involving sheets. If you solve, then you can do fast calculations. Memorizing the multiplication tables, continuously memorize the multiplication tables, have speed drills in this, and recall your multiplication tables for division. Simplify calculations into smaller, easier calculations. Do a few small calculations at least once a day. Vocalize your mental process to yourself. Saying the numbers and process aloud will make you hear the calculation as you work it out. This adds a new layer of learning and memorizing on top of what's already there. Try to do as much as in your head as possible. Mental calculations leads to fast calculations also. Moving ahead, understanding the correlation between the concepts. Now, light from lower grades to higher grades, how does student must correlate a subject? For example, if you have a concept of parallel lines, the definition which is taught in lower grades is the distance between the lines which is maintained the same is nothing but called as parallel lines. But as you move into higher grades, the concept must be understood as the lines which intersect at infinity are nothing but parallel lines. Now, even if you have for example, a circle where a tangent is touching, there is a point so from the center to the point of contact. Why the line is perpendicular? From any point to a line, the shortest distance will be always perpendicular. Now, in the lower grades, we understand the relation between percentage, fraction, and decimal. For example, 25% is there. We understand it as 1/4. The decimal form will be 0.25. 33 1 by 3% is there. It is understood as a fraction as 1 by 3. In the decimal form, it is understood as 0.33 recurring. 66 2 by 3%. It is as a fraction, it is 1/3. And decimal, it is 0.66 recurring. Now, the first derivative of a function, when you see either it is greater than 0 or less than 0. If the first derivative is greater than 0, it is a strictly increasing graph. It is a strictly decreasing graph. Now, this actually can be observed in calculus. Now, how you can correlate this subject? If a function is a strictly increasing or a strictly decreasing function, this is a 1-1 function. Now, correlation exists between functions and calculus. Now, for example, we see an algebra formula is there, a plus b the whole square is equal to a minus b the whole square plus 4ab, where we can say that a plus b the whole square is always greater than or equal to 4ab. When product of two numbers is given to you, the numbers are each equal to uh, a plus b if it is a minimum value, and then correlation exists between algebra and calculus. The same thing can be analyzed in calculus also, that if the area is minimum, then what will happen? The maximum rectangle which you can inscribe in a circle is a square. So this is how the correlation between algebra and calculus is. And then the correlation exists in geometry and calculus also. The correlation exists between vectors and three-dimensional. For example, a unit vector, how it is analyzed in three-dimensional. It is analyzed as direction cosines. So like that, the correlation exists between subjects or the topics which we learn. Moving ahead. Now need to have skills and short tips and some concepts. Now what happens is when the concepts are digested by a student, then while answering a problem, either it may be in Applon or any other competitive examination, the time taken by some of the problems will be very less when you solve it differently. Now, what are the short tips which can be understood? For example, the factorization which comes, for example, if I have x squared minus 4x plus 3, this can be factorized as x minus 1 times x minus 3. Now there we can observe, if I take the same thing as y is equal to x squared minus 4x plus 3, this becomes a parabola where it cuts at 1 and 3 on the x-axis. So these are the x-intercepts, and it cuts y-axis at 3, that is the y-intercept. So what all can be understood from the graph also, if you draw the graph, you can observe that what is the vertex, what is the y-intercept, what are the x-intercepts, what is the distance between the x-intercepts. All these six can be identified. Even when a circle equation is given in analytical geometry or coordinate geometry, how to identify the radius and the center. Or if there is a line joining 2 points and the midpoint is given and one of the extremity is given, how to find the other extremity, there is a short tip for that. For example, if the midpoint is x1 plus x2 over 2 and the other coordinate is y1 plus y2 over 2, if you have the one of the extremity as x1, y1, you can double the midpoint and subtract from the one of the extremity to get the other extremity. This is a short tip. Now, again, splitting an algebraic expression into factors, as I said earlier, it is also a short calculation. And then when a line is given, for example, in a graph, a line is given. Now, from the line, you can observe what is the slope, where it is cutting x-axis, where it is cutting y-axis. Now, what is the slope of the equation? What is the equation we have? Even we can analyze some short tips like, for example, what is 6% of 50 can be analyzed as 50% of 6. Here you are swapping the numbers. So 6% of 50 is same as 50% of 6, and ultimately it is 3. For example, if you have 4% of 25 or 25% of 4, it is nothing but both are same. So the answer is 1. So just swapping the numbers, because 4% of 25 can be analyzed as 4 over 100 into 25, which can be written as 25 over 100 into 4, which is 25% of 4, that is 1. Now moving ahead, how to prepare for performing well in competitive examinations. Now, actually, the student, while joining universities, he has to write some competitive exams so that by that rating, he has to join the university. Then the fast calculations, which we learn right from lower grades, will be very helpful in competitive exams. Most of the competitive exams have MCQs. Now, if they have MCQs, either by eliminating the options. Now, if you understand the problem and if you're solving the direction of the problem, now what happens is you can eliminate the MCQs. For example, only one answer will satisfy. Why the other options are not satisfying? For example, you must get a positive answer. Three options were given negative. So you can go with that positive option without even solving the problem. So this actually time consuming will not be there in the competitive examinations, and the rest of the time you can put it on the other problems which are application mode or a bit lengthy problems. Now, while eliminating the options, sometimes even we find a result wherein if you want to get it as a decimal value only, for example, and the others are given as integers, and directly you can tell that is the answer. So having all these in our mind, fast calculations or mental calculations by seeing the problem or by understanding the options will give the result very well in competitive examinations. Moving ahead, understanding word problems. Now, word problems are there both in NAPLAN, or if you take SAT or ACT, you have word problems designed. Many students struggle with word problems, and this lowers their confidence during the exams. So what we have to do? The word problems are mostly created to stimulate real life situations so that students can relate to them while solving them. Most students get confused while reading and interpreting word problems. The best solution to it is to break the word problems, break the sentences, break them into sentences, what is given, simplifying them into simpler parts, and taking the information given in the problem, what is given and what is asked, moving in the direction of what the result must be. That would be fine in solving the problems. Generally, word problems are nothing but they ask in probability, they ask in statistics or exponentiation or a geometry problem where the figure will be given and you have to analyze the problem, what the question is. So word problems actually generally they are asked, so break them and then understand them, what is given in the problem and what is to be solved. Then moving ahead, analyzing graphs. This is very important. Many problems can be solved from graphs. Now, a graph is a diagram that is meant to represent data and to portray a relationship. Now, for example, as I told earlier, a linear graph. From the graph, you can analyze slope, x-intercept, y-intercept. You can even analyze the equation. For example, the question may be if the given graph is a linear graph, a line graph, and a perpendicular line to this line is asked, then also we can find very easily from the options given. Now, this is all about linear graphs. Now, if you come to quadratic graphs are nothing but parabolas. So already I told you earlier that parabolic graphs can be having the question as the vertex, the x-intercepts, the distance between the x-intercepts, the y-intercept, whatever it may be. And then we have the trigonometric graphs. In trigonometric graphs, the amplitude, the periodicity, everything can be questioned. Now, this is again related to functions chapter. Now, exponential graphs are there. We know that the exponential graphs are always above x-axis. They are always positive. And learning logarithmic graphs. Now, what is a logarithm? What is the base given? Whether the base is given greater than 1 or whether the base is given lying between 0 to 1. If you can analyze from the graph, then easily you can find the solution. So graphs play very important role. And even the inverse trigonometric graphs. So for example, a 10th grade student learns 3000 graphs in some areas. So how many graphs we learn right from the lower grades to the higher grades? That is very important. And analyzing, not only knowing the graphs, you must be able to even transformation of graphs, you must know. How, for example, I gave a parent graph y equal to absolute value of x. If I give you y is equal to absolute value of x minus 1, the graph shifts horizontally onto the right side. Now, if I give y is equal to absolute value of x plus 1, it shifts to the left side. If I give y is equal to absolute value of x plus 1, it shifts vertically above on y-axis. If I give you y is equal to absolute value of x minus 1, it moves vertically downwards on y-axis. Y is equal to absolute value of 2x. The graph actually gets compressed. If I give you y is equal to absolute value of x over 2, the graph actually, it bulges. So how to analyze the graphs? So transformation of graphs also must be understood. And many solutions you can get from graphs. Moving ahead, how is mathematics made interesting? Now see, the teaching methods, what we apply, that makes mathematics really interesting. So generally the students has a phobia of maths, phobia of numbers called as a number phobia. Now to eliminate this right from the basic grades, if the students understands the concepts, learning the concepts by real life examples, imbibing them, writing all the formulas in a formula book, and then keep on writing the formulas without saying, then you can understand what maths is. Right from lower grades, the foundation must be laid properly. Then the misconceptions. There are many misconceptions in maths. If you really want to learn a concept, so if you know the misconcept, for example, if you have x squared, the whole cube, it is not equal to x power 5. It is equal to x power 6. So then why it is not equal to x power 5, if you can understand, then really the concept you can learn. For example, in general, we write x power m whole power n as x power mn. Now, if you are learning fractions, let us suppose a over b plus c cannot be written as a over b plus a over c. So all these misconceptions, if a student knows, then I think you can make maths more easy. And then, for example, in functions, why a function is not satisfied. So if you can draw a Venn diagram understanding why a function is not satisfying, then you'll understand the real definition of a function. And then understanding the extension of the concepts is also more important. Let us suppose when geometry was introduced, if two parallel lines are cut by a transversal and the corresponding angles are equal, as you move on to the higher grades, those are nothing but angles of inclination. And even, for example, let us suppose I'm introducing distributive property. Now, when you introduce distributive property to a child, now what happens here is you have to analyze them first by an example. Now, for example, if I give you that two chocolates are distributed to a class consisting of 10 boys and 5 girls. Now, total it is 10 plus 5, 15, 15 times 2 is 30. So you need 30 chocolates, where 2 into 10 is 20 chocolates to boys and 2 into 5, 10 chocolates to girls. So if I teach this and then if I put it generally as A times B plus C equal to AB plus AC, then that is the distributive property. Or for example, even I can give you an example as a rectangle where the length is 20 and the width is 4. So then 4 times 20 will be 80. That is what you can analyze the area of the rectangle. No, you break the rectangle, the length you have made a break, 15 and 5. So 4 times 15 plus 5 is also the area, because 4 times 50 is 60 and 4 times 5 is 20. 60 plus 20 is also 80. So there also distributive property acts. Not only this, so the interesting topics are, for example, I deliver that plus into plus is plus, plus into minus is minus, minus into plus is minus, minus into minus is plus. Now, how these came, if can be analyzed with the student, then really you will understand, instead of memorizing it, how it came, why minus into minus is plus, why all these things are there. Now, similarly, I can give you another example as the sum of a positive number with its reciprocal is always greater than or equal to 2. Now, this can be analyzed from the algebraic formula. As I said earlier, a plus b the whole square is equal to a minus b the whole square plus 2ab, or arithmetic mean is greater than or equal to the geometric mean. So that application also can be made, or you can go with calculus also. So the same problem can be analyzed in three different topics: algebra, you can introduce, or the series, arithmetic mean, geometric series, or the same problem can be analyzed even in calculus. Now, for example, the divisibility rules also. If you have the units place of a number which is divisible by 2, then the whole number is divisible by 2. The sum of the numbers is, if it is divisible by 3, then the whole number is divisible by 3. The sum of the numbers, if it is divisible by 9, then the whole number is divisible by 9. And for 7, actually divisible by 7, we have a trick that, for example, if you are given 343, now you strike off the units place 3 and make it double. 34, in the remaining number, subtract double of that number. 34 minus 6 is 28. 28 is divisible by 7, so the whole number 343 is divisible by 7. Now, this I told on a 3-digit number. If you have a 4-digit number, strike off the, for example, if I give you a number as 8638, so cancel 8, the units place, double it, subtract. Again, do continue the process until and unless if you get a number which is divisible by 7, then the whole number is divisible by 7. If you are getting a number which is not divisible by 7, then the whole number is not divisible by 7. This is fun. And you can make even fun by involving some activities, puzzles, games, making the subject interesting. Moving ahead. Now, learn Max the Turito way. Learn concepts with real life examples. That's what I told one example, distributive property. When a student understands a concept with real life example, never he will forget that particular concept. He will remember throughout his life. Now here in Turito, we have an active teaching, and the engaging is there with the student by continuously asking him whether he has understood the concept or understood the problem. If he has not understood the direction in which we tell the problem, we try to take other directions so that the same problem can be told in a different manner. There is a two-way interaction continuously with the student, so that there will be a nexus between the student and the teacher, and eliminating misconceptions. Misconceptions, as I told, for example, if I divide 2 with 0, am I getting 0 or am I getting 2? So 2 divided by 0 is undefined. So for example, if you are writing root over x square plus a square, is it x plus a? So all the misconceptions, if they are eliminated, the student will understand the real concept, and right from lower grades to the higher grades, the journey of mathematics will be very smooth. Building confidence and clarity. So while a Turito teacher explains concepts or problems, the confidence builds in the student because he is able to understand everything, and the clarity is given that, see, this is how you must solve. So here we have get motivation for both correct and incorrect answers. If the student has given a correct solution, then he is applauded. And at the same time, if he is giving the incorrect answer, we will show that why the answer is wrong, in which direction he went through. This is a wrong direction of thinking. So the thinking ability also will develop from the Turito teacher. Ditch the fear of maths by building interest. So interest, as I told you, that the maths, when it is told with puzzles, games, and activities, it builds a lot of confidence and interest in the subject. Thank you very much.
Thank you, sir. Thank you so much for detailed explanation about the topic, sir. We'll be ending the session now, sir. We'll be having a webinar session in the upcoming week as well. We hope to see you all again. Until then, if you have any queries, please write to us at care@turito.com. For more info, please visit our website www.turito.com. Turito makes every student to learn mindful but not handful. For better learning and better results, join Turito. Thank you. Have a nice day.